Alright, there we go. I think we got it. We're good. Alright. So this is where we were last time. We had a list, a variable, and then a simple for loop with the range. And remember the range is if you want to just loop a certain number of times, or you want to set I to a specific number as you're looping through. But most times we're just going to use when you're looping through a list or any other iterable, you're just going to use a standard for loop, which is for the element inside of the list. So in this case, we're going to do num because, well, you can name this anything you want, but num because these are numbers. And then you can do anything with the numbers. You could say, you can print them, you can add something to them, you could multiply them. Oh no, whatever you would want to do inside of your list, essentially. And then, yes, so that's for loops. We can do while loops too now. William, you have anything to add for loops?
I don't think so. No.
Yeah, they're pretty simple. They just loop through iterators, and I don't know if I showed you this last time, but you guys can loop through lists also. Sorry, let's not set that to X. You can loop through lists, and usually you would change num to letter because these are letters now and not numbers. But if you look down here, it's printing out string string. So lots of things you can loop through in Python. For loops are super useful for just cutting down on the amount of code you write, not having to write things over and over and over again, because computers can just do it better and faster. So we'll do a while loop. So let's comment this out. And if you guys remember the comments, multi-line comments, you can use either 3 single quotes or 3 double quotes on each side, and it prints everything out. Comments everything out. Alright, so while loop is while a certain condition. Let's say we have a condition of, let's just say x is true for now. You can say while x, so while whatever is true, so in this case x, and it's always going to be true because x is set to true. It's set to a boolean. Remember, we have booleans, either true or false. So right now it's being set to true. And what a while loop does is it's going to continue looping until a certain condition is met. So right now it's just going to continue looping forever. So if we were to say to print hello, this will just continue looping. It's an infinite loop, and as you can see down here, it's just continuing to print it on and on and on and on and on. So in this case we would have to stop it. But you can do a lot of other stuff for this. A while loop is going to be used when you don't necessarily know when you're going to get to an endpoint. Like, you don't necessarily know how many times you want to loop. So if you have a while loop, it can check for the certain condition and then just stop looping then. So for instance, if you would say you have a variable x, change this to 1, and then you have a variable y, 5. This is kind of just a simple explanation just to show you guys. But while x is not equal to 5, as you can see, it's not equal to 5 right now. Obviously it's 1. Y is 5. Oh, this should be y. You can set it so that x gets, let's say, x plus 1. And this is remember when when we were assigning variables, when we're assigning variables, so x gets x plus 1 is not an algebraic equation, you're not going to solve for it. So x is getting x plus 1. So in this case, x would be initially 1, so 1 plus 1 is 2, and it sets the new variable 2, and it loops through again, 3, loops through again, 4, loops through again, 5, and then eventually, once it gets to 5, this condition is gonna be false. So whatever is here, once it becomes false, it ends the looping, and you're done. So if you want to see what it looks like, we'll print out the x values as we go through. So it's just gonna count up 2, 3, 4, 5, right? Because it's being added, or yeah. And if we were to put this here, you would get 1, 2, 3, 4. At the last one, it sets it to 5, and then once x is equal to y, so because x is not equal to y is the condition. If x is equal to y, this is false, and then the while loop stops looping, and you exit out of the while loop, and you could print something like exited or whatever, right? And you can tell that we're out of the while loop. So this would not be an infinite loop, obviously, because we exited out of it. So that's pretty simple. William, you want anything to add to this? Want to add anything?
You can also do the x plus equals 1.
Yeah, exactly. Good point. Yeah. So this is just the way we learned before to change up a variable or do anything to a variable. X, you could do x plus 1, x minus 1, right? X divided by 1, which is not going to do anything. X times 1, also not going to do anything. But if you want to be cool, like a cool programmer, you can just write x plus equals 1, and that will do the exact same thing as x plus whatever, x plus 1. You do x plus equal 2, x plus equal 3. So yeah, that saves time. And by the way, if you were to do it this way, this is going to be an infinite loop, because it's going to go from 1 to 4, and then 7, and then 10, right? It's never going to hit 5. It's never going to be equal to y. So we're just going to continue going. As you can see, the numbers go real fast. So that's while loops. Pretty simple stuff. Alright, cool. Why don't we hop into functions? And that's the last thing I want to go over, and then we can just start hopping into the very basics of the tic-tac-toe game, and we can start assembling your own games. Alright, does anyone have any questions for while loops and a recap of for loops? So basically, for loops, you're going to be using that if you know how many times, either you know how many times you want to iterate, or you're iterating over a specific iterable, like a list, iterable or iterator, list, or a string, or a dictionary, or like an array eventually, when we can do numpy arrays. You can all loop through that and just chug each element, go that way. While loops is you don't necessarily know when your condition is going to be satisfied, so you can set that equal to whatever condition you want, and when that condition is satisfied, you just go into or exit the while loop. So you can have a continue looping until a certain condition, whatever you want, is satisfied. And when we start doing Pygame, if you guys want to do Pygame, it's basically set up as a while loop. It's set up as an infinite loop until either you win the game, or you press exit, or you press a button to exit, or something like that. So if you want to think about the practical applications of a while loop, that's one of them. So there you go, while loops and for loops. Is everyone caught up? Does everyone also have an IDE open and they're just not listening to me ramble? Because it's more useful if you code as we're going along. So does everyone kind of have either Replit open or PyCharm open? If not, I can help you with that.
Yeah.
You guys are all good. I showed you last time. I'm not sure if there are any new members here. If you guys need help on that, you're completely lost right now. I have no idea what I'm talking about. I could quickly go over just how to open Replit. Are we good there?
Yep.
All right, excellent. That sounds good. Okay, cool. All right, one more thing. Last thing, functions. So functions are super useful. If you want to think about it, you don't ever need a function when you're programming per se, but you really do need a function when you're programming. Functions are like little specific packages of code. Um, not even packages, more like just a grouping of a code, like a little bit of a little subsection of your program that say you want to use over and over again. If you want to think about, like, say I wanted to, in our tic-tac-toe game, assign a like a certain square a certain value, x or o's, right? You're going to be doing that at least 9 times throughout the game, and you don't want to be writing that code over and over and over again, because that's just extremely tedious. It's unreadable when when people are reviewing your code. They're going to be like, why do you have these things repeated? You can cut down on the code. It's not elegant. It's not a simple solution. So in Python, in programming in general, there's a thing called a function. And when we go to like object-oriented programming, there's class-specific methods, but we'll worry about the functions right now. So to create a function, you're going to do def, which is obviously short for definition, and you can name your function whatever you want. So, oh, by the way, if you want to look, I haven't really gone over the there's Python has a bunch of built-in functions, and if you want to just Google them, they're actually super useful. I think you've already seen 2 of them here. Print is one, and range is one. Those are built-in functions. But Python is really, really, really handy because they have all of these built-in functions that you guys can use. And oh, we also saw string before, when you're turning, say, a number or integer into a string. That's a function, built-in function. So Python has a bunch of these built-in functions, and then when you start getting other packages, they have all those super useful functions. And that's really the beauty of Python. You can write a lot of code really simply. They have a lot of built-in functions. You don't have to go in and write your own like power function. So power, for instance, would raise numbers to the power of something. So base and then exponent, just like in math. If you want to raise 2 to the whatever, like a millionth power, you could do that way. Absolute value, that one just gets the distance away from 0, just like in math. What else is there? What else are some super useful ones? Max is really useful. If you want to find the max of a I'll show you what that looks like here. So basically, print is a function, max is a function. A function, you can tell it's a function, by the way, if there are parentheses. You have the name of the function, and then there's parentheses, and then inside of those parentheses are called parameters, and what you put inside of that dictates how it operates or what it does, right? Or like the input you want to have. So for instance, if we uncomment out our list, and we want to find the max of the list, oh boy, this is commented now. Get rid of, yeah, let's just move this here, and then we'll comment this out here. Oh. Alright, move this down. So you have the list up here, and then you have a max, and you want to print the max of the list, for instance. In other programming language, you would have to loop through and then like set a temporary variable to the maximum, and then compare each of the other elements in that list to that temporary variable. In Python, it's much easier. You just do print max, and boom, you get 10. The max in list is 10. And if you guys are interested, like, finding the max in any list is super simple. You just write a for loop. Oh, you know what? We can write our own find max function, and you guys can see how basically if you had to write your own max function. But Python, if you want to just check this out, these are the pythondocs.org. Just Google them. These are just super useful functions that you can use every day. Obviously, there's print here, range we've already used, round for rounding, string for turning things into a string, sum. adding things. Min just like max. And also there's also help, which just helps you out with all the stuff, all the Python stuff. But these built-in functions are really what make Python so accessible and so user-friendly, really. So why don't we write our own max function? So does everyone kind of get what like a function does? It does a specific operation, or has a specific use, and you saw the built-in functions, but we can also write our own, and this is where like you can do a bunch of stuff with programming. So like I said before, def, and def is for definition when you're defining a function. So we can do we'll do my max, and inside of my max you're gonna want to put say like a list, right? Because that's what you're going to be putting into the function as an input. So what this is called is a parameter, and you can make up your own parameters, whatever you would like. You don't even have to have a parameter. For instance, if we want to just, oh, by the way, if you don't want your function to do anything, or you don't want your code to do anything, you can just write pass in. It just doesn't do anything. But say we have just like, we can have any function you want, really, like a print poop function or whatever, right? This wouldn't be useful at all to us, but because you can just do print. But say you want to print poop a lot of times, and you want to have a specific function for that for some reason. William, you have any other examples that are super simple? But it doesn't matter, I guess.
You could like input a list and then just loop through the list to find some value.
Yeah. Okay. Oh, that one has a parameter. I just want to show without a parameter. Parameters are like, you need parameters, but this is like as simple as it's gonna get. This is not even useful for your coding, because you can just save a line and write print poop. But say you want to have a function that prints poop. So you write this function, and I believe you're supposed to, I believe in Python you define your functions and then you go. I think in Java you write your code and you define your functions underneath. I don't think it really matters though. Anyways, you have a definition for a function now. So you've already written it. Remember, we have parentheses, we have a colon, which indicates that this is inside of the function. And now if we want to call your print poop, all you have to do, just like printing, the ID recognizes that it's a function, by the way, and all you have to do is that. It's just giving me an error. Doesn't matter. Oh, I think it's a spacing error. Yeah, it wants me to add more spaces. Anyways, so now we just called the function, and if we run this, you're gonna get poop. So now you can run this over and over again as many times as you want, wherever you want in your function. And this hasn't really saved us any lines, but say we want to print like, no, I don't know. This is just a simple demonstration of what a function is. But basically that's what a function is. I'm just trying to demonstrate that you don't need a parameter, but you do need these parentheses, or else it doesn't understand what you're trying to do. And if you're looking at code, whenever you have these parentheses and parameters inside, you know it's a function. Alright, so why don't we make our own max function. There's already a max built into Python, so this is completely useless and a waste of time. However, it is just a practice. So if you're looping through a list trying to find the max, you don't know where exactly the max is in the list, so you have to loop through every single element basically. There's not really, that's basically the easiest way. Also, like a pretty generic example of a function is like a sorting function, and that's like one of the first things that people do. They just make a sorting function. We could do that too if you guys are interested, but not that interesting. It just sorts a list and by like list from least to greatest. Doesn't really matter. You can look that up online if you guys are curious. But anyways, So we have a parameter now, which is slightly different, and you guys can actually set the parameter to a default value if you're like so inclined, but we don't need to do that for now. In the future you can do that. So you have a parameter list, and you don't have to set the parameter to any like type like you would have to do in Java, because it's Python, super flexible. And now you can just loop through the list. Oh, you need a variable, by the way. So we can set this variable to, let's see, what would we want to set this variable to? Okay, you can set the variable to the first element in the list, which, if you remember, is indicated by 0 because it's 0 indexed. So now you have an element x, which is set to the first variable, or first element in the list. You have a variable x set to the first element in the list, and that's going to be a number. And now you want to loop through the rest of the list and compare the initial variable x to the other values. And if you find a value that is greater than x, you assign it to x, right? So now we have a greater max. So we can create a variable for that too. So we can call it just temp max, right? So it's temporary max. You don't, no, wait, my bad, sorry. X is the temporary max. Yeah, confusing myself. Okay, yes, so you have to have good variable names. Okay, so x is the temporary max. When you're listening through a list, you're gonna go to your first element, and you're gonna be like, wow, it's a 1, it's a -1, it's a -100. That's my temporary max, because I have no idea what's the rest in the list. So we'll set that to the temporary max just for now. And then as you loop through, so you can do for num in list, and then now you can compare each element num in the list to temporary max. So you would need an if statement for this, right? So if temp max is less than num, or actually it makes more sense if we go the other way around. If num is greater than temp max, go inside there, you set temp max equal to num. Does that make sense for everyone? Just the kind of logic there. So you're looping through each element in this list. Why don't we move this list down here? So initially you set temp max to list at 0, which is 3. And now you're gonna loop through each element in this list. It's gonna go for num in list, so it's gonna look at 3 first. We don't need to do that, just a loss of efficiency, because obviously it's gonna be equal. So it's gonna first compare 3 to 3. If num 3 is greater than temp max, if 3 is greater than 3, which is not, so it doesn't enter the if statement, nothing happens. And then it will continue going on into the list. So it'll compare 6 and then 7. 6 is greater, so temp max is going to be set to 6. Then 7 is greater, so it's going to be set to 7. 6 is not greater than 7, not going to be set to 7. 7 is not greater, so etc. Right? It goes to 10. It finds temp. 10 is the temp max. And now you have this variable. You have 10 sent to temp max, and you need to get 10 out somehow. You need to get 10 out of the function. And how you would do that in a function is a return. You just return, and then you do temp max. And what a return does is it like poops out it poops out the whatever you want to return. And once you hit the return, even if I had code down here that said like print something, print hello, it's never gonna enter this, even if it's inside the body of the if statement, or the body of the what you call it, function. Once you hit return, it's just exits out of the function. The function stops executing. So even if I had a bunch of code afterwards, blah 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 blah, right? It's just never gonna get down there. And even if you put this inside the for loop, and it might not necessarily execute, if it does execute, it's just gonna stop. So that's pretty self-explanatory. It's kind of like it just kind of quits it out, right? There's even a function called quit, but we don't have to go over that right now. So this just completely quits it out, and let's see if this works. So we could either call by max, and then assign to list. These two are the same. They don't have to be the same. It just so happens that this is a list and my parameter name's a list, but no problem there. If we run this, we get 10. So what's happening is it goes through all this logic and it returns the temporary max, which in this case is 10. It doesn't have to be. If I added other numbers to this, say 12, right, it's gonna return 12. And then it gets to the if statement, and it gets to the return and returns whatever 10 max is assigned to. Does that make sense for everyone? Like, you have this little packet of code now that you can use over and over again as many times as you want with my max. Does that make sense? We went over parameters. Any questions? If you guys have used other programming languages, it should be pretty self-explanatory. But Python is just simpler. You don't have to define what kind of variable this is. You don't have to define if it's like what kind of scope the method is, for example, in Java.
Talk about local versus over. You want to talk about?
Oh yeah, local scope and global scope. Yeah, sure. So when we're looking at functions and when we're looking at the entire program, you have a global scope, which is just like if you look at the whole wider program, you have, if these were uncommented out, you would have an X variable, you would have an str variable, string variable, you would have a list variable. These are all global variables. They're global and they're in the whole entire scope. And this is a global function, right? It's like inside the main thing. It's inside the main programming body of the program. When you go inside of the function, you're in a local scope now, because it's limited to what you have in here. This is just going to look for what's in here, and then it's going to look for what's outside the global. But you can have local functions too. You can define a function inside of a function, and then you can define other functions inside of that too. It gets kind of confusing. But for example, temp max is a local variable inside of here, inside of the function myMax. If you were to look for if you want to print temp max outside of myMax, it's not going to be able to find it because it's in the local and it's not in the global scope. So if you were to print like temp max, it's going to throw you an error because it has no idea where it is. You never defined it in the global scope. So what you normally do is you return something, and that will allow you to print it out. And also, it's generally not good programming practice to change variables from inside of a function. You would generally want to return it. So it's doable, but some cases it does not work. So it's generally good programming practice to return whatever you want to return. I actually think I might have done that in here. Yeah, maybe I think so, maybe. So it's okay, it works, but you should return it. So do as I say, not as I do. But if you, for an example, like this is not gonna work. If you, like, for example, num is in the local scope of the for loop. You wouldn't be able to print num even inside of the function itself. So if I want to like print num outside of the for loop, does it work? No, it shouldn't work. I don't think. Let me try. Yeah. So it's not going to print anything because, I didn't call a function. My bad. Yeah, let's see if this works. Yeah. So it's not printing anything, right?
That means you can use like the same variable names. Like
Yeah. Good point. Yeah. So if I had a temp max out here, well, yeah, it gets confusing at that point. So try to like keep your variable names different. But if I say had another for loop or another def max function, and instead it was like my min, just the opposite, we can keep these the same. You can have another num, and you can have another temp max in here, and it's not going to interfere with here, because these are local. Temp max and num, they're all local to their local scope, so it's not really a problem. even though these two functions are going to do the same. But if you were to like swap this, now you have a print num function. So we can even try it out. Hopefully it works. It should work, right? Alright, so what was the min? Yeah, so there you go. This one does the max, and this one does the min. Where did we print max out here? Did we do it?
Hey Kevin,
Yeah, what's up?
is list a reserved word or is that a custom variable name?
Oh, that's what I called it. Yeah.
Okay,
You
it's not
can,
a reserved word.
no, you can call this whatever you want. Oh, is it a reserved word? No.
Okay.
No. I mean, there might be a list function. No. No, it's fine. Don't worry about it. Yeah, generally you're fine. Yeah. Okay. It's giving me an error. Object is not subscriptable. What did I do? Oh, sorry. I changed this. So, yeah, it doesn't really know if you try to, like, if you put in a list but it doesn't exist. You can call this whatever you can call the parameters whatever you want, by the way. I'll just use list because this is a list. So this prints out the min, this prints out the num. So there you go. Pretty simple. If you were to write this out, you would change these variables. But other than that, there you go. That's functions. Is everyone cool with that? Remember local, global scope. Global scope is the entirety of the program. Local scope is inside of your function, inside of your for loop, whatever. Does that makes sense? Yeah. Alright, great. Alright, yeah, okay, we're recording still. Good, okay. Let's begin with the Tic-Tac-Toe game. It's not too bad, it's only like 59 lines, that's nothing. But if you want to look at the Tic-Tac-Toe game, you have a print board, that's a function. Yeah. There you go. In PyCharm, you could like kind of clear out the code if you don't want to stare at it. But this is the Tic-Tac-Toe game. You have a board variable, which is a list of lists. It's a 2D list. And you have multiple functions. So we have 1, 2, 3, 4 functions. And then I just call play. So play is not really necessary, but I just like to have everything in functions. And this is the code that's actually like outside of a function. This is the only bit of code that is what is this doing? This is the only kind of code that is not like, for example, it's the only kind of code that is this, or in the global scope, I guess you could say, kind of. No, the only code that's not inside of a function, and also the board itself. So there you go. Why don't we begin with this why don't we begin with programming this game? So I'll create a new project, and we can reference the old one as we go along. Alright, cool. You know what? No, we don't need a new project. We'll just create a new file in here. Alright, so is everyone on the same page? They have a brand new project, brand new Python file. Yeah? We good to go? Yeah. You don't need to make a new project, but it's probably be useful. I guess you could put it on the current project. Just make a new file. And if you guys haven't seen this before, I think I showed it to you before. It's just super simple game. Oh, sorry, running the wrong one. Here we go. It's a super simple game. You have a really super like basic board printout, and you have just these inputs. One, you put in 2 like coordinate points basically that correspond to a certain board position, and it places things there. And it doesn't really need to be more complex because it's tic-tac-toe, and who cares? You can make it more complex, but at the end of the day, it's just a game, and we're just using it as a learning experience. Alright, cool. So why don't we stop this and we can begin. So first of all, you're gonna want something to hold the board and each of the variables inside the board. As you can see here, it's a list. So we're gonna create a board variable, set that to a list, and inside of this list we're gonna put other lists, because although you can do just like a one large list with 9 values inside of it, 9 elements inside of it for each, it's just easier to do it. Have like one list for the first row, one list for the second row, one list for the third row. It's 2D because we have a 2D board, so we're gonna have a 2D list. Make it simple, and we're gonna set this list initially to, I believe, yeah, just spaces. So it's pretty simple. And once you have one of them, you can copy and paste. You could either keep it like this, but it's a board, so we'll put it in the board to look like an actual board. Alright, terrific. Now we have a board, and we can print the board actually. Oh, wrong one. Run this, and it prints out a list with spaces in the variables, the elements, because we haven't assigned it to anything yet. Alright, so does that make sense for everyone? The list inside of a list, 2D list. Yes? Anything in the...
Wait, you explained like what each list represents, right?
Yeah, it's the row. Each row of the board. Yeah. Yeah. Kind of thought it's just gonna hold the values we have. Alright, let's move on to the print board function. So we need to print each when you are playing this game. We need to print each value, and like we need to print the board out each time we're gonna have another input, because if you don't know what's on the board, then you can't play the game. Okay. So we'll have a new function called def print board, print underscore board. And yeah, you can put like, I guess if you have multiple boards, you can have board in here, but right now we're not going to worry about that. All we're going to do is check out the board above. Alright, so what we're going to need is a numbering system, right? We need to have, oops, my bad. We need to have these numbers here if you want to have your players know what to, like what place they're going to be placing their thing. There's no buttons, so you need to have like some kind of coordinate system. So this is spaced properly, and you can like play around with it, but I already know this is spaced properly. So for the first, let's say like row of it, like not row, but for the first line of the like kind of game, you're gonna have just some spaces. These are just spaces, and then 1, 2, 3, and I think there's 1, 2, 3, 4 spaces, and then there's 1, 2, 3, 4, yeah, 4 spaces in between each of these variables, or each just numbers. And if you want it to be like, you can start with 0 too, or like 0, 1, 2 if you want to be all programming savvy, but because it's 0 indexed. But we're just gonna do regular numbers because we're humans and we start at 1. Okay, terrific. Now we need a for loop to loop through each of the lists inside this board list, and then print those out too. So we're gonna do for list or let's use better variable names for row, because we're gonna be printing out each row. For row in board, and what this does is it doesn't go into the individual lists. It just treats each row as one of the elements inside the larger list, because that's what it is, and it prints out the entire list just like that. prints out the entire list. It doesn't go into each individual one. Well, it like doesn't. You don't need to do that. Basically, is what I'm saying. For row and board, and then you can just do print row. All right, let's run this. Oh, we didn't call it. My bad. Print board. Okay. All right. There you go. So you kind of got a board, right? But you don't have the coordinate system, the coordinates for the rows. You only have the coordinates for the columns. That's not useful. So what you can do is you can either have a counter variable that you initially set to 1, and then inside the for loop you just add 1 to each time. So for example, you have a counter, and we use counters all the time in programming because they're super useful. Counter, you can set that to 1 initially because that's what we want, and then like you're gonna be printing the counter, and then you're gonna add 1 to the counter. There you go. And that, oh, you know what? That doesn't do it properly. Here. So what you would need to do is you wouldn't print them on the same line. You get rid of this one and you put a comma, and that will print both elements. So there you go. Now we have a board. What I did before is, if you like want to continue and be smart, and I mean not be smart, but you want to be more elegant with your code, let's say, but perhaps a little more confusing with your code, you can use a function, a pre-built function called enumerate, which what it does is it poops out 2 values, it poops out a count and then a row. So it will give instead of just having 1 element that it returns and then is assigned to, say, row, it's gonna return 2 values. And if you remember in Python, you can do this because you can like assign x, y gets 5, 4, 5, right? That's perfectly fine. You can do that in Python. You can assign as many variables as you want in just 1 line. And essentially, that's what enumerate is doing. It returns 2 values, and the first value is being assigned to count, the second value is assigned to row. And what enumerate does is it just acts as a counter. So it returns, I have it set to 1 initially because we want to do 1, 2, 3, but if you don't have anything here, okay, so if you don't want to have anything here, you can have it like that, and it's going to return 0 to count. But we set it to 1 initially because we want to count 1, 2, 3 instead of 0, 1, 2. All right, so this is the easy way to do it, and I'll show you the other way to do it. So for
Hey, Kevin.
yeah, what's up?
Dr. Go, is there anywhere I can follow along with this code like later on?
Oh yeah, sure. Sorry. Why don't I show you guys? So what I've been doing is I have all the meetings here that we had before. So if you guys want to look over that, I don't have the Java recording, but I do have the Python recording from last time in the first meeting which we had. And also we have Python tutorials in our website, which is cbsouthcoding.com, or you can just Google CB South Coding Club and it should be like the 3rd result. And we have the how to install Python, we have strings, variables, comments, if statements, and or elif lists, for loops. So I've been putting all whatever we do during our lessons into these, like they're only 13 minutes, like 9 minutes long. I've been chopping them down and pooping them into the website, so you guys can go back and look at that. So there you go. That answer your question, Tommy?
Yeah, thank you.
Yeah, no problem. All right, great. Yeah, we all staying along, not too bored. You wanna? We'll probably just, if we can go longer, but we could just end it at like, yeah, we can just end it at the print board, or we can even do check for winner, which is pretty simple too. But I guess, yeah, why don't we just continue? I'll show you guys how enumerate works. So for you're gonna want two variables here. We'll get rid of this. All right. So you're gonna want two variables for count and row, just like before, except they're both inside the for loop now. For count row and then you do enumerate whatever you want to enumerate over, which in this case is board. And then you could set, this is the start integer, and it says right here, whatever, like we can start at 3, and then if you run this, oh, my bad. Print row, I didn't print it out. Print count row. Alright, and this needs a colon. So if you look down here, we get 3, 4, 5. But that's super confusing, and we want to keep it the same as before, so we'll just start at 1. By the way, if there wasn't anything here, it just goes 0, 1, 2. So we're gonna start at 1. And there you go. You got your board printed out. And if you add variables into here, right now you can add whatever you want. And this is gonna totally mess up the format, but it's gonna print it out. So you have now you can actually play tic-tac-toe and know what's going on without having to guess where everything is and remember everything. So that's super useful. Does everyone understand how print board works? It's quite simple. This doesn't do anything. Yes? William, have anything to add? it's pretty basic right now, so
Oh yeah, it's pretty easy.
yeah, okay, great. Alright, let's see, what do we want to do next? Do we want to do get move, or we could do, yeah, why don't we check for a winner? There's like, if you want to look down here, there's totally better ways to check for winners, but I'm just gonna do the most simple way to check for a winner, which is to compare each element in the row with each other. And instead of basically the problem with this is not scalable. You can't move up into like 4x4 or 6x6 or 7x7s. You can only do 3x3. If you want to do more of that, you would have to change the code. And typically in programming, you don't want to do that because you want to have stuff code that's like robust and doesn't require your effort to fix in the future, right? You want to have it so that it's future proof. But for now, doesn't really matter. So, all right, let's make a new function, def check when. All right, terrific. So we'll probably just check for horizontals today, and then unless you guys want to continue, we'll do check for verticals and diagonals another day. But check for horizontals is pretty simple. So just like before where we loop through each list in this massive 2D list, we'll do the same because we want to be comparing the lists with each other. So for for row in board, if, and you can do 0, this is just a equals equals. Remember, equals equals is how you compare two things if you want them to be equal. Row 0, row 1 equals equals row 2. You can yeah, what did I have it return? Okay, I have it return a winner. And you can just return the first element in the list. So for instance, if X wins here, say X wins here, what you would want to do is say that X wins, right? Not like O wins. And you can also print like winner, def winner, return true. So there's a winner, but that's not as useful as printing or returning like who won specifically, right? In this case, X has won. So why don't we check if this works? There you go, X, right? Because in this case, X has actually won, and no matter, and the printing just like the first element in the list returns the X as a winner. So yeah, that's quite simple. However, the problem arises when you don't have anything inside. Now if you run this, it's still going to say there's a winner. You can't see it, but it's printing, say like it's printing a space out right here, because it's printing, these are all equal to each other, and it thinks there's a winner still. So you need to have an AND condition that checks if the row is completely filled or not. So you want it to be not equal to a space, right? So what's happening here is it's checking if someone has won, so if these all match up, and that row is not equal to a space. In this case, although this condition is satisfied, right, these are all equal, so this is true, but these elements are all spaces. Row 0, that's a space, right? It's not equal. I mean, yeah, it is equal to space, so this condition is false, and it's not gonna say anything happened. It's not gonna say it's not gonna return anything, which is what we want. Does that make sense why we did that? Yeah?
Yeah.
Okay. Excellent. So now we have something that checks if there's a winner, basically. And by the way, if you run a function and it's supposed to return something, but it doesn't return anything because this condition is never satisfied, so it never gets to the return, it's going to just spit out a none, which is correct in this case because there is no winner. So when we check for a winner, there's no one because these aren't equal to each other. And these ones don't have any input in them. But if you want to check if, there you go. So obviously there's a winner down here, and you have check winner, X is the winner. Alright, that's an hour. So we can end it here. We got the check for horizons, and if you want to practice good coding, you just comment your code. So check horizontals. Alright, cool. I think we can stop there. We printed out our board, we have a board variable, and we check for horizontals. And we did a bunch of other stuff today, while loops, for loops. Yeah. Functions, parameters, local, global scope. If you guys want to stay on, I can continue, but I think it's getting a little boring, so we can call it a day. Everything will be on the website, so you guys can watch it over, and I'll upload our the Learn Pi code onto GitHub, which if you guys don't know how to work it, it's on the website. You go to home, nice helpful resources, you click GitHub, and then you have all of the stuff that we don't have that much stuff right now, but we'll be adding to it. And GitHub's a code repository, so say you want to check out the Tic-Tac-Toe game that I was referencing, you can just go into GitHub, and there you go. You can download this code, you can copy and paste the code into your own IDE, you can mess around with it, do whatever you want. So that's how you guys can access the code that we work on. And eventually when you guys make your own stuff, we can upload it onto here, and then you can show it to everyone. You can share it with everyone. Cool?
Yep. Yeah. Thank you.
Yeah, no problem.
Thank you.